Assuming that we have a list of integer numbers like this, the algorithm virtually divides the input list into two parts. The first part is a sorted sublet, which is built up from left to right at the front of the list. And the second part is the unsorted sublist, which contains the rest of the list. Initially, the sorted sublet contains the first element in the list, while the unsorted sublet contains the rest. At each iteration, we will consider the leftmost element in the unsorted sublist, find its correct position in the sorted sublist, and then place it there. So now I want to sort the list by ascending order. Let's start with the first iteration. Consider the number 4. Compare it with the previous element. 4 is smaller than 5, so we swap them. No more element in the left of 4, then it is already in the right position. Now the sorted sublist contains two elements, 4 and 5. Let's start the second iteration. Consider the number 2. Compare it with previous element. 2 is smaller than 5, so we swap them. Continue to compare it with previous element. 2 is smaller than 4, so we swap them. No more element in the left of 2, then it is already in the right position. Let's start the next iteration. Consider the number 8. Compare it with previous element. 8 is larger than 5, so it's already in the correct position. Let's start the next iteration. Consider the number 6. Compare it with the previous element. 6 is smaller than 8, so we swap them. Continue to compare it with the previous element. 6 is larger than 5, so it's already in the correct position. So now, no more element in the unsorted sublist, so we have our list sorted in ascending order. So what is important to remember about the insertion sort? The first, insertion sort is a simple and very easy to implement. Second, insertion sort is an in-place comparison sorting algorithm. And the last, the time efficiency of insertion sort is quadratic, which makes it inefficient on large lists. However, insertion sort is one of the fastest algorithms for sorting very small arrays, even faster than quicksort. Indeed, good quicksort implementation use insertion sort for arrays smaller than a certain threshold. The exact threshold depends on the machine, but is commonly around 10. So that's all about insertion sort I want to share with you. Thank you and see you in the next video.